Hello everyone, and welcome to MAT 1033 Intermediate Algebra, no matter what my screen may say up there, okay? I want to go over some first day of class notes with you and then some basic solving equation review questions or problems so that you can get back into algebra. Many of you have been out of it for a while now, and we want to take you so that you go through this course and you're completely ready to go into college algebra, which is MAC 1105 as your next course. Now, the first thing I want to make sure is that you have gone through and looked through your Blackboard course. You've done the Start Here folder. You've gone through and printed out your syllabus, schedule of activities, and you've looked at the lab. It's either my math lab that you're working in, or it's going to be my open math, depending on which version you get of this course. There's going to be a diagnostic exam that you're going to take, but before you do that, this first day of review might really help you. And then, of course, for the online students, there will be a PDF upload, and some other notes are there for hybrid classes. But basically, this is how we're all going to get started. Now, first, this problem that you've got on these guided note pages that you have printed out or picked up from me is going to be something you're going to work with me. You're going to work through these problems with me just like I'm writing them on the board and you're sitting in the classroom. Or if you think you want to try it ahead of time, then go ahead and stop the video, try the problem, then come back and see the solution and see how you're doing. Basically, this first example, example 1, is an example of an equation that we have to go through some steps to actually solve it. And anytime you have an equation and you're asked to solve that equation, what they really want is they want the variable, the unknown, the letter that's inside the equation to be equal to a certain number or something anyway. And so this one is the variable, the unknown in this equation is y. It could be anything. It can be x, and usually it is x, but for this example, we got y. So we're going to look at first the left side of the equation and then the right side of the equation. The equation is split into two pieces by the equal sign. Now on this left side, I've got to first distribute multiplication if I have any. That's my first thing I'm going to look for. And when I have a number outside, two numbers or two terms inside parentheses, what I have to do is multiply that number times each of those. So I'm just going to kind of draw an arrow here from the sign that's in front of that number to show that I'm multiplying it times a positive 4. So really what I've got, I bring down the 2y and I say 4 times y. Well, that's a positive 4, so it would be a positive 4y. And then I multiply that positive 4 times a negative 8. And that's going to give me a negative 32. Now I'm finished with that side of the equation, so there's my equal. Over here, I'm going to distribute the negative 4. Again, I distributed a positive 4, and now I'm going to distribute a negative 4. So that's a really good thing to remember, is that the sign that's in front of the number that you're distributing or you're multiplying sticks with that number. So this time I'm going to multiply times a negative 4. But first I'm just going to bring down that 8y because nothing's to be done in this first step with it. And negative 4 times y, of course, gives me a negative 4y. And negative 4 times, what's the next term? Well, it's a negative 10. Negative times negative gives me a positive, and that would be a positive 40. Now, once I have done that, there's nothing else to multiply on either side. So I look to my sides again, and I say, do I have like terms? Well, any term that has the same variable, the same unknown, is a like. Now, this one, these are both y's, right? And they're sitting here together, so I'm just going to put a block around them to show we're going to combine those terms. We're going to say 2y plus 4y gives me 6y, and I don't have anything to combine with my number term, my numeric term, my negative 32. I'll just bring it down. Over here, I say 8y minus 4y. Well, 8 minus 4, right? Gives me a 4y, and I'm going to bring down my 40. Now I'm to the point where I've simplified each side of the equation. In other words, this one, these two terms are not like, these two terms are not like. They can't be combined. I have no multiplication to do. I'm ready to start switching things from one side to the other. I want all of my variable terms, my unknown, to be on one side. I want my numeric terms to be on the other. Well, I have 6y over here and I have 4y over on this side. They're both positive. Which one is bigger? The 6y. So I choose to work with the smaller variable first. Just my choice. You could do it the other way, but if you do it the other way, you're going to end up dividing by a negative, which is much more confusing. So let's say I want to get this 4y to go to the other side. Well, I subtract it. Is this ringing a bell? Anything I do to one side, I do to the other side. That's how it stays an equation, right? So I'm going to subtract 4y over here. Well, when I subtract it, go back to the right, I say 4y minus 4y is 0. Bring down your equal. So what's left over here is just plain old 40. But I have over on the left side, I've got 6y minus 4y, I get 2y. And I can bring down my negative 32. So I got 3y minus 32. Now, I need the y to be isolated, so I need to get rid of a negative 32. I will add a positive 32 to both sides, right? That's how it stays equal. And then I'm going to have to move up here to do this. This side is going to cancel. These 32s are canceling each other out. Negative 32, positive 32. All I have left over here is 2y. It's equal to 40 plus 32, so that's going to give me 72. Next step, I just have one term on each side of the equation. That's when, and the only time when, I will be able to do division. So what do I divide by? Well, I look at the coefficient of my variable. It's a 2 in front of it, so I'm going to divide by 2. Why? Because that'll cancel and give me just plain old y. Now, over here, I have to do the same thing. I have to do the same thing to both sides of an equation. And 72 divided by 2 is going to give me 36. I finally got the answer I needed because y is equal to a number and y is equal to 36. I can check it. I would plug in 36 in the original equation every time I saw y. Plug in 36, solve that equation, and it should come up with numbers that are equal to each other. Next, let's look at an equation that is a bit more of a challenge, and because we all love fractions, right? And this one is fractions in my equation. I've got 3 fractions. I have 3 terms. Remember, terms are separated by addition and subtraction or an equal sign. So over here on the left, I have 2 terms. On the right, I have 1 term, and they just happen to all be fractions. It doesn't have to be, but they are. So I look at them, and I look at my denominators, the lower part, and I say, I need to get a common denominator for these fractions. In other words, what would that common denominator be? What would the least common denominator be for 2 and 5 and 4? So I want the smallest number that all 3 will divide into evenly. Now, I know it has to be at least as big as 5. So I'm going to start, I'm going to work with multiples of 5 until I find it. 5 won't work because 4 won't evenly divide into 5, and neither will 2. So I'm going to say 5 times 2 gives me 10. That's my next multiple of 5. And 10 won't work for 4. So I'm going to go up one more. I'm going to say, what about 15? Well, 15 won't work for 4. It won't work for 2. What about the next one, 20? 20 works for 5, 20 works for 4, and 20 works for 2. My least common denominator is going to be 20. All 3 numbers, 2, 5, and 4, would evenly divide into 20. So what do I do with it? Well, I want to clear the fractions. And this is the first thing. You're going to hear me say it a lot. Every time you have an equation with fractions, your first step is always clear the fractions. Wouldn't you rather work with an equation, have to solve an equation that didn't have any fractions in it? That's why your first step is to get rid of the fractions. How do you do it? You find the least common denominator and you multiply every term in the equation times that number. Okay, so I'm going to multiply each one of these times 20. Now I'm going to write this one over here because I didn't give much room. And I'm going to write it as a fraction because I'm multiplying it times a fraction. And it doesn't matter which side I write it on, right? And this one over here times 20. All right, what happens when you multiply 2 fractions together? Well, you can cross-reduce. You can reduce any numerator with any denominator. So this 20 and this 2 will both divide by 2. If the 2 becomes a 1, the 20 becomes a 10. That becomes a whole number. What's the whole number? Well, it's 10x over 1, which is clearing the fractions. Okay, so now we're going to say plus. What about this one? I can say 5 and 20 do reduce. 5 will divide evenly into 20. And it becomes 4. So then I multiply 4 times x, and I have 4x over 1. I don't have to write anything that's over 1, right? And the next one I'm going to reduce is going to be 4 and 20 over here. And so I've got 4. We'll go into 20. That'll give me a 5. And I end up multiplying 5 times 5. I get 25. There was no x in that one. So what is my equation really that I've got to solve? 10x plus 4x is equal to 25. Well, over here, let's go ahead and combine like terms. I got 14x is equal to 25. And then I've got the final step, division, right? Divide by the coefficient, the number that's multiplied times your variable. And I'll end up with x is equal to, well, that's not a really nice fraction, is it? It's okay. We started this equation with fractions. We are allowed to leave our answer in fractional format too. So we'll just say 25/14. If we could reduce that, we would, but we can't. Let's go on to example number 3. For number 3, we've got another set of another equation. It's a little more complicated, isn't it? The first thing to think about is, okay, it's an equation. See the equal sign? And it has at least one fraction in it. In fact, they're all 3 terms or fractions. Now, I know the numerators have multiple terms in them, but it doesn't matter because this fraction is considered a single term here. So I'm going to go ahead and put these numerators in parentheses to show that for right now, I'm going to treat them just as a single item. And I'm going to look for my least common denominator. My least common denominator, I've got 6, 3, 8. I'm going to work with multiples of 8 because 8 is the biggest number. I say 8 won't work. It would be nice if it would, but what about the next number up? What if I tried, what's 2 times 8, right? That'd be 16. Will 16 work? Well, okay, 16 isn't going to work. What about 3 times 8? 3 times 8 gives me 24. 24 works for 8, 24 works for 3, and 24 works for 6. I'm going to use 24. I want the numbers to be as small as possible, so I want to pick the least common denominator. Now, once again, we're going to multiply these fractions times 24 over 1. This is just a fraction. No matter how complicated the numerator is, we're just going to treat it as one item, and I'll show you how it works. 24 will cross-reduce with 6. Ignore the fact that these 2 terms are up here sitting on top of that 6. It doesn't matter in the least. What am I going to do? I'm going to divide 6 into both 6 and 24. Now what do I have? Well, I have 4 multiplied times n minus 5. Okay, I don't want to do that step together with it. It's just too complicated. I'll write it down. Next, I'm going to say plus, this one is 3 and 24 have got to cross-reduce. And 8 is my 24 divided by 3, right? So I've got 8. Let's put that 8 in front when we write this term down, because that's normally where we do it. And we'll say 8 times n plus 2. And then this is going to come over to the equal sign, and I'll reduce the 8 and 24. And I'm going to say 3 times 51. Since I'm writing everything down, I'll just go ahead and write that down too. I got more steps to do in this problem. Next, I look over here on the left. Distribute multiplication, right? I have to distribute this 4, and I have to distribute the 8, and then I've got to do some multiplication and some combining like terms, but let's do that first. I say 4 times n, well, that's going to give me 4n. 4 times negative 5, well, that's going to be a negative 20. And then I say plus 8 times n, well, that's going to give me a positive 8n. And 8 times 2 is going to be a positive 16. And then I'm going to come over here and say, what is 3 times 51? Well, 153. I can do that one in my head. All right, next, let's get these like terms together over here on the left. I've got some n terms. I'm just going to put squares around them, and I'm remembering that the sign that's in front of the term is the one that determines whether I add or subtract, right? So 4n, positive 4n, positive 8n gives me a positive 12n. And then I've got a negative 20. And a positive 16. Now, these are not the same sign. So I'll basically subtract them. What's the difference in 20 and 16? Well, it's 4. Do I want it to be a positive 4 or negative? Well, this bigger number is negative, so it's going to be a negative 4. So I have 12n minus 4 is equal to 153. I need to get rid of the negative 4 because it's over here clouding up my side with the 12n, right? So I can add 4. That'll help me get rid of a negative number. Move up here to the top. 12n, these 4's canceled, is equal to, and it's going to be equal to 153 plus 4, which is 157. We're at the end. There it is. So now what do? Well, now I divide. Divide both of them by 12. The 12s will cancel each other out. Anything over itself is the number 1, right? So n is equal to 157 over 12. Now I would check that and see if it would reduce. The first thing I'm looking at is saying, okay, does 3 go into both of those? 3 goes into 12, but what about 157? And if you check it, it doesn't, but 3 has a nice little trick. If you add these digits together, 1 plus 5 is 6, 6 plus 7 is 13. Is 13 divisible by 3? Well, it's not, so 157 is not divisible by 3. It's not an even number. It's not divisible by 4. You can try a few numbers, and you can try it with your calculator if you want to, but that's the format that we'll probably end up leaving that one. All right, we've just got one more page in this little section we're doing. So let's take a look at the top of the next page, and we're going to see example 4. The word problems. Yay, we love word problems. We love word problems, and we love fractions, right? Okay, the sum of 3 consecutive integers is 75. What are the integers? And integers are just numbers, so let's not worry about it. Let's just say they're consecutive, and they're integers, which means they're just separated by 1. They're the next number on the number line, okay? So what I'm going to say is, I'm going to say the first integer. I have to lay out word problems. I have to put it down in words so I know what I'm talking about. I'm going to call the first one x. And I need the others to be represented in terms of x, because I can't really call the next one y, and then I would be solving for an x and a y. I don't want to do that. I need just one unknown. So I'll call the second integer. What do I know about it? Well, it's 1 more than x, isn't it? Consecutive means it's just add 1 to each one. Okay, so we know the second one is x plus 1, and you know what the third one is by now. It's going to be the next one in the sequence, x plus 2. So what else do we know about these numbers? Well, we said the sum of them is 75. Now, is always means equals, right? Sum always means add. So I'm going to add these 3 numbers together, and it's going to equal 75. So in other words, I say x plus, the other one is x plus 1. That's integer 2. And the third one is x plus 2. And they're all going to equal 75. Now, did I need to put anything in parentheses? Well, no, I didn't have to distribute any multiplication or anything, so there's no reason for parentheses. I can now look at it and say, well, I have 1x, and there's a second x, and there's a third x. You can, when there's no variable in front, there's no coefficient in front of my variable, rather, it's a 1, isn't it? So this is 1, 2, I've got 3 x's. And then I say, okay, the numeric terms, I've got 1 plus 2. Okay, so that's plus 3. And this is all equal to 72. This is looking like something easy to solve. I need to isolate the variable term. So I got to get rid of a 3. I'll subtract it to get it to go away or go to the other side. I now have 3x all by itself, and it is equal to 72 minus 3. So what is 70? I'm sorry, this is supposed to be 75. Guys, you picked that up already, didn't you? Sorry. Pretend that's a 5. So 75 minus 3 is a 72. That works, right? And I now have just division. 3. Each side divided by 3. And this is going to make it x is equal to, and that would be 72 divided by 3, 24, right? Calculators are allowed, simple calculators. So if you have something that looks like this, you are fine, okay? But I think I've got that right. So x is 24. That's the first number. Well, the next number is x plus 1. That's going to be 25. And the third number is x plus 2. Well, that's going to be 26. 3 consecutive numbers that added together will equal 75. Now, let's take a look at solving for variables that really, this is what I call algebra without the numbers. They told us, they gave us this sort of a formula here, and they said solve this one for f, okay? And solve for f means this variable f needs to be on one side and everything else needs to be on the other side of the equal. Okay, but it's kind of in a messed up place here. It's inside parentheses where I need to distribute this term, which this unknown, this m, is really representing a number. So we're going to treat it just like we would treat a number. We're going to say t is now equal to, and let's distribute the m. Let's say m times 7, well, that's 7m, isn't it? We always write the number first. And then the next one is going to be m times fg, positive fg. So I'm going to say fgm. We usually write these alphabetical. So that's why I'm choosing to put the m last. So I've got t is equal to 7m plus fgm. Now I need to solve for f, so this is the term that needs to be isolated. I need to get rid of this one. It's a positive 7m. How do I get it to go to the other side? Well, I'll subtract it from both sides. Now that zeroes it out over here, and I have just fgm. And what's it equal to? Well, it's equal to, I can write it like this, t minus 7m. That makes sense to me. I could say negative 7m plus t, but this is better. I need to solve now for f, right? Now, solving this thing for f means that g and m have to be canceled out somehow. I've got one term over here. I'm just going to do my division. I'm going to say divide by gm. That'll cause them to cancel, won't it? And I'll have just f. But I have to take this entire side and divide it by the same thing, gm. So here is my answer. I'm going to switch it around so that f is listed first. F is equal to, what does this say? T minus 7m over gm. Now we look at that and say, okay, it looks like I could reduce it, doesn't it? I mean, it looks like I could reduce these m's, but hang on. You don't have all multiplication in the numerator. You've got two terms. So unless you can reduce both of those terms by m or by g, you can't do any reduction at all. So this is its final format. All right, let's take a look at changing, looking at a formula, really. The formula for taking Fahrenheit and going to Celsius is sort of like this. We have something that's 88 degrees Fahrenheit. We want to know what it is Celsius. What do you do with that? Well, you Google it, right? And you just get them to do it for you. But this is the formula that actually goes behind that. The first thing that I'm going to do is come over here and plug in for this Fahrenheit degrees the number 88. So I'm going to rewrite this equation. And it's going to say Celsius is equal to 5/9, 88 minus 32. Those are the degrees. And that would be multiplied. Let's go ahead and figure out what that is because it'll be much easier for us. We say 88 minus 32. And that came out to be, okay, well, it's 56, right? I've still got to multiply it by 5/9. And that's still what Celsius is equal to. My unknown is C in this case, okay? So now I've got a fraction in an equation. Now this is the only fraction there, but that's okay. Since it's the only fraction, what's the least common denominator? Well, 9. Let's multiply it times 9 over 1, right? Now, it's already being multiplied times 56. So I don't have to worry about multiplying anything times 56 because this is all multiplication over here. 9s are going to cancel. And this one has to also be multiplied times 9 over 1. Multiply both sides of the equation by the same thing. Since multiplication glues terms together, this really is just one big term here, okay? All multiplied. So I only had to multiply it times 9 one time. I go over here and I say this is 9c is equal to, what is it? Well, it's equal to 5 times 56. And I can plug that into my calculator and say, what's 5 times 56, okay? Well, 5 times 56 is going to give me 280, I think. See if I did that right. Check me out, okay? Okay, it looks right to me. I've got 9c is equal to 280, and now I'm going to divide both sides by 9. C is going to equal, well, let's see, 280 divided by 9, and I get 31 point, and it keeps going. My calculator kind of came out with this answer, 31.11111. Well, we can put another 1 up here for the decimal, and we can put a line over it that says it repeats forever. It's just going to keep on going. So we've got 31.1. And what is this? This is degrees Celsius, right? So what is 88 degrees Fahrenheit? 31.1 degrees Celsius. Okay, that's our first introductory lesson, and I'll see you in the next one.